I want to do a really quick review of our shapes that we've talked about so far. So ellipses, circles, and hyperbolas. When we are classifying, so once again, if I give you an equation, it's not in standard form, and I'm asking for you to identify the type of conic it is, you don't have to get it into that standard form in order to identify. So we've already talked about these separately, but I just want to refresh our memory with them all together. Remember, if you see a general equation where everything's on one side, it equals 0, you have an ellipse if you have your two squared terms and they are both positive numbers in front. You'll have a circle if you have two positive squared terms. However, their lead coefficients have to be equal. So with the ellipse, while you have two squared terms, one of the numbers in front could be like a 2 and another one could be a 10. So the numbers in front of the squared terms could be different, but in terms of a circle, they have to be both the same number. And then when we're dealing with the hyperbola, if we have squared terms, but they have opposite signs, it doesn't matter if they have the same number in front or if they don't. If one is positive and one is negative, it makes it a hyperbola. So here are some different general form equations. Let's identify and classify the conic. So if we look at the first one, notice that I see my squared terms are right here, a negative x squared and a positive y squared. So even though the number in front is the same, the signs are different. So remember, that tells us then if the one is positive and one is negative, we have a hyperbola. If I'm dealing in problem number 2, where my squared terms both have a positive 4 in front, so because they're both positive and they have the same lead coefficient, that would then be classified as a circle. Looking at problem number 3, if I look at my squared terms, I see one of the positive numbers in front of the x squared is 49, while the other one is a positive 16. So two positive numbers, but both different numbers. That means that we have an ellipse. So take a second, look at this fourth one, and classify the conic. So hopefully you were thinking, all right, we've got one positive x and I have a negative y squared. So when we have opposite signs, we are thinking hyperbola. Another important piece of information that I hadn't talked about would be eccentricity. Now, we've talked about that with ellipses, but we can also determine the eccentricity of hyperbolas as well. The formula is the same. It's still E equals C divided by A. However, when we were talking about an eccentricity with an ellipse, our ratio was always between 0 and 1. This time, if it's a hyperbola, when we divide the C and the A, we should be getting something that is greater than 1. Okay, so the closer the ratio is to 1, the more narrow the graph will be. But this time, if we get a number that is bigger than 1, it's a hyperbola rather than an ellipse. So here I want us to write an equation of a conic given the following. We have a center at negative 5, 6. One vertex is at negative 5, 5, and the eccentricity is 3. So nowhere in this problem am I telling you what type of conic it is. So that's why looking at the information, it's going to be important for us to identify what we have. So the moment we're talking about eccentricity, we're going to be thinking either ellipse or hyperbola. And in this case, since the eccentricity is 3, that tells us that because it's greater than 1, we're going to have a hyperbola. All right, so remember, it's going to be that C divided by A is going to equal that eccentricity. I'm going to write it as 3 over 1. Okay, so hopefully we're then very aware that the 3 is our C value and A is actually 1. So A is 1. We don't know what B is. I know that C is 3. And so if I know 2 out of those 3 variables, I know that C squared equals A squared plus B squared. I can plug in the numbers that I know and I can solve for B. So I know that 3 squared equals 1 squared plus B squared. Well, 3 squared is 9, 1 squared is 1. I have to move the 1 over by subtracting, so I get that b squared equals 8. I could take the square root and get b, but when I'm writing my hyperbola, I know that I want my squared term on the bottom, so I can just leave it as it is. Remember, when we're talking about a hyperbola, we're always going to put the a squared term first. And since a is 1, squaring 1, we get 1 on the bottom, and then b squared was 8, so that's our second denominator. Okay, so we know that we have a center, and so I know that I'm going to have a positive 5 with the x and a negative 6 with the y when I plug them into my equation. We just have to determine, when we have a hyperbola, is it going to be the x term first or is it going to be the y? And so to help us figure that out, we're looking at how the center moves to the vertex. So if I'm looking at these two ordered pairs, notice that it's the x values that stay the same, which tells us that to go from the center to the vertex, we had to move up and down. So that tells us that our transverse axis is going to be the y. So that's why I know that I have to put the y first. So I'm going to have y minus 6, quantity squared, minus, and then I'll have x plus 5, quantity squared. And that gives me my equation.